Welcome, everyone. Thanks again, as Kate said, for attending Basel University. This is introduction to our DGC-2020HD. We're going to cover the agenda as kind of the product line highlights, and then we'll get into the HD basics, the applications, the communications, and then the software tools that we use for programming and monitoring. One of the highlights for Basler is the reliability of our products. As you see on the far right is our lower end model. There's also a 2020, and then the HD. Today we're going to focus on the 2020. But what's nice is they're all very similar in form, fit, function. Here's some of the easy use that we like to talk about. Obviously, there's multiple applications that can be utilized. It's a standardized HMI, and they all use the same navigation. The settings are done through the front panel, or it can be done through our BestComms Plus software, which we'll talk about a little bit later. The HD, as we're going to be talking about further today, also offers a color touchscreen that you see in the bottom right. For our product line, here's all the functions and features that we have within these products. So as you can see, like I said, the ES is actually our lower end model. The 2020 is middle of the range, and then the HD is our upper end range that we'll get into some of the applications, and you'll see that the features and functions of that are pretty massive. For the other capabilities, again, as you can see, the HDs cover all of this stuff. We also have the option for having programmable inputs and outputs. So you can see as the HD, we've got 16 programmable inputs, 3 defined digital outputs, and 12 digital outputs that are set for 2 amps. Analog inputs, 2 are standard. We have an option of going up to 4. Analog outputs, there are 3 in total. 2 of them are programmable. So we'll carry on. Some more features, obviously the ruggedness and the able to withstand harsh environments. A lot of these HDs go into places like oil fields, marine applications, outdoor gensets, highly configurable. So you can basically use one piece of hardware for multiple different applications, ideal for mission critical. So we'll talk a little bit more on some of the accessories and why that gets us that mission critical options. Color touchscreen, as we talked about, full sensing and metering capabilities, both voltage and current and protections. The one thing that is an advantage to the HD is we have the capability of having 2 separate bus sensing and being able to control 3 breakers. It's definitely a thing that leads us in the industry. So not only the ruggedness, but also the ability to have 3 circuit breakers being controlled at the same time. Very expandable, configurable, condition monitoring for email alerts. So in the HD, you can set it up so they will actually send out email alerts during any warnings or alarms. And then what we call segmented bus, which is very flexible, and we'll get into some of that a little bit. Further features, we got 2 analog inputs that are standard, 4 that are optional. Basically, what we utilize is if you're not using analog inputs like a resistive or analog oil temperature or pressure, we can repurpose those, especially when you're using an electronic engine, which most of the engines today that are being manufactured are all tier 4 final or stage 5. Programmable bias outputs for the AVR and the governor. So during load sharing and bar sharing, the HD can actually control both the governor or the ECU and can control voltage regulator. It can either be a Basler, which there's a wide array of Basler AVRs that are out there. So I would encourage you to possibly attend another Basel University that talks about our AVR lineup. We can also do zero power transfer, which that means basically when you're paralleling the utility, the HD will bring the generator into sync, close the generator circuit breaker, and basically it goes to a zero power transfer and then increase load to whether you want to do a base load or whether you're going to do a closed transition. It can also do the same thing on the way down. So as you start to unload the gen and return the power back to utility, it will go through a zero power transfer. Those settings are also adjustable. So if you want to set it as a 10%, just so you don't have an opportunity to be able to go into reverse power, that's all very highly configurable. We have a wide array of CAN bus programs already set in the BestComms software for the electronic engines and AVRs. So as I had said earlier, there's programmable bias outputs. That can be a digital, it can also be analog, or it can be through a CAN bus, as long as the AVRs accept a CAN bus input. We also have a ground fault and neutral fault current protection already built in. Auto synchronizing is on board. Load sharing obviously is on board as well. Breaker control and monitoring. Exercising function. So a lot of times customers will want to try and exercise the unit at least once a week, if not every other week, maybe even just once a month. We have a very extensive capability for setting up exerciser functions, full 7-day calendar, full 24-hour clock. So it's very configurable for what the customer needs from an exercise capability. Email capabilities as well, as we talked about, and then 3 programmable LEDs on the front that are for enunciation. So as the operator walks up to the HMI on the front screen, there's also 3 LEDs that can be programmed, and there's an Avery card that slides in behind, so you basically can print off, and it's a standard Avery card, so you can download the Avery software free, print out what you want to program those LEDs for, slide the card in, and then through BestComms program those LEDs accordingly. Breaker power summing, so this allows us to be able to look at multiple breakers and figuring out which way the power is moving. It's a pretty important feature sometimes when you're paralleling the utility. We offer both peak shaving, base loading, demand start and stop, which demand start and stop means you can have multiple generators and they'll actually sequence themselves on and off as the loads demand. And then segmented bus, so we can have the capability of being able to control 95 breakers. 32 of the breakers are gens, 63 are bus tie breakers. Quite a wide range of communications capabilities. So on board, we've got a USB mini B for programming. There are 2 CAN ports. Those CAN ports can be used for I/O expansion modules, voltage regulators, or electronic engines. We also have RS-485, which you'll see later as I show some of the accessories, the remote display panel, which is required for NFPA 110, and then the capability of using Modbus RTU to speak with building management systems as needed. There are also Ethernet ports too, and they can be either a single fiber or a dual copper option. In the dual copper option, we offer a redundant DGC to DGC communications, so that if for some reason the wire gets broke between one or another in a multiple gen application, the redundant DC communications on the Ethernet will take over. Then we also can utilize one of those Ethernet ports for Modbus TCP IP, and we can also utilize that for the email alerts that we talked about earlier. Another form of communications we have on board is RIG-B, standard protocol for the utility tie communications, and then RS-232 for external modems or GPS. Also loaded inside the software is pre-configured sensor curves, and there is a selectable option so that you know that you're using like a VDO sensor. A lot of the times we have those already pre-programmed, and you can just select it and download it. We also have programmable sender curves. So if the sender curve that you're using is not in our pre-configured selection, you can actually build your own sender curve through a table built into the BestComms. We also offer a full line of protections. So there are, as you can see, all the ANSI numbers, and you can see quite an array of the number of that we allow to program. So you can have up to 6 over voltage, which is ANSI 59, 600 voltage, and they're all configurable. And then you can also utilize a configurable table curve as well for those protections. We also have multiple curves that we can design and make. So short time, long time, instantaneous type of stuff to be able to have protection for the generator mainly. So once you get the alternator generator specifications, you can build a curve that actually will protect that alternator from damage. We have multiple methods of mounting. We have a front panel, both standard and colored touchscreen, as I talked about earlier. We have a rear mount that is a DIN rail or a rear mount that's fixed. And then we also offer a complete sheet metal control panel that is completely wired from the factory to terminal strips and ready for installation. Works really well on a lot of times when customers are looking to do a retrofit on an older unit. As we talked about earlier, on board paralleling, so it's just a quick little single line diagram. The DGCs are controlling the generator. It's individual generator circuit breaker, and then supply and a load. We have both dead bus close arbitration, which means the two DGCs will talk, or multiple DGCs will talk back and forth to each other. And if they all get the start signal at the same time, they make sure that only one tries to close the circuit breaker first, and then the rest of them synchronize to that live bus. Field bus close is if you're in an application where you want to have multiple gens on the bus as fast as possible. What will happen is the DGCs will get the start signal from a transfer switch or switchgear, PLC, etc., and they will first close their generator breakers and then start the unit, and they all come up and synchronize basically as in a slip type of frequency synchronization. And then basically once they're all online, we start exciting the voltage regulator, and then the voltage builds up. So again, kind of important for life safety loads, especially if you're in need of something that's 10 seconds or less for NFPA 110. Dead field close works very well. Style numbers. So as I said, the hardware is pretty much the same, but one of the things that you'll need to understand is once you get the single line and the sequence of operations designed, understanding what some of these options are so that you can order them. Some of the style numbers can be reconfigured in the field. Some of them have to be ordered because the hardware does change a little bit internally. All of our certifications, so you can see that we pretty much cover most of the certifications around the world. CE for Europe, UL for United States, CSA for Canada, NFPA 110, and then both EAC and ABS for marine and other applications. So I'll jump right into the accessories. Again, I've got a chart here but as we talk about the HD, you can see that it's extremely flexible and expandable. So this contact module we'll talk about in a minute, analog module, and then the remote display module, and you can have up to 4 each of those. So up to 12 accessories on one DGC-HD. The remote annunciator is utilized for NFPA 110. So it has both audible horn and then 17 programmable LEDs. And it's RS-45 connection. Again, there's a style chart to help you understand how to order. The contact expansion module, there's 10 dry inputs, 24 outputs, 1 amp DC form Cs, 4 amp DC form Cs, and then this utilizes CAN communications to the DC. You'll also see the analog expansion module is very similar, 4 to 20 milliamp, 0 to 10 volts, or RTD, thermocouples, all that's configurable through the BestCom software. Quick little diagram of the RS-45 communications to the different accessory modules. We also have a IDP, which is an interactive display panel, 7-inch and 12-inch color touchscreens, all pre-configured. So basically it's pretty much plug and play. You buy one, you install it, and it instantly communicates to the DGC-HD and starts displaying in its full function. So you can start, stop, read alarms, warnings, etc. This is done by Ethernet, so it's slightly different than the other accessory modules, but Ethernet. And so if you do use an IDP, you'll need to be able to make sure you have one of the Ethernet ports accessible, and also make sure that you're the style number with the Ethernet option and not the fiber optic option. Some of the applications, here's the terminals. This is the back panel. You can see all the terminals laid out, clearly labeled. One of the applications is just a simple single gen and a load bus. So this would be pretty much like a islanded mode type of unit, rental program, etc. In the BestComs, you'll see that as you select what type of application you have, it will actually show you a single line diagram as well. This diagram is found in our configuration manual. So I would encourage everybody, if they want to learn more, to get that configuration manual and then look through some of this. Single gen and a load bus. So now we're controlling not only the generator circuit breaker, but we're also controlling the utility circuit breaker or the main circuit breaker. Gen load and mains bus control, so GCB and MCB control as well. multiple gens. So again, as I had stated earlier, we can parallel up to 32 gens together. This is an application where each one of the generators would parallel, as you see up in the upper side, gens 2 through 32. They would parallel to the bus and then a group breaker. We can also do multiple gens, one group breaker and the load breaker. We also have the capability of doing multiple gens, the group breaker and the mains breaker. So as I had stated earlier, this is one of the highlights for the DGC-2020HD is we're one of the only few in this industry that can actually control 3 separate circuit breakers, and we have full sensing both voltage and current for all of those. And as you can see, I put in here configurable for these breakers, so we can configure the HD to be able to control any breaker that's out there. Segmented bus, I mentioned earlier. This is when you have multiple generators that are tied together with a segmented bus and the group breaker, being able to control and sense. So one HD can control the generator circuit breaker, the generator group circuit breaker, and then go on to a segmented bus. And then on that segmented bus side, you can have another DGC HD that can actually control a tie breaker, which that's kind of what this is illustrating. So if you remember going back a slide, we had this segmented bus A, and then we have a tie breaker. Now we're showing segmented bus B. My contact information, if you've ever got some applications that you want to consider and have a discussion, this is my direct contact information, my cell phone and my email. Talk a little bit more about the communication side of things. So we covered a few of these things already. But as you can see, here's your communications ports on the back. J1939 communications for your electronic engine control. So we follow all the SAE standards. So we not only are communicating with the ECU, but we actually have the capability of displaying the Tier 4 and Tier 4 final and Stage 5 icons that are standard for SAE. We also can read the DTCs, which is the diagnostic trouble codes from the ECU. So a lot of the times operators at the genset side of things don't have the software tools to be able to look at what the DTCs are in the ECU. The DGC-HD will actually pull those DTCs and display them on the HMI. And then with that J1939 CAN bus, we also have the capability of controlling speed and kilowatts to the engine. We have load sharing lines. So we talked about multiple generators in one application. We have multiple different methods of being able to communicate. So as I stated earlier, we have the Ethernet load sharing lines. You can see at the bottom. So each DDC will go to an unmanaged industrial Ethernet switch and then get daisy chained between DGCs. We also have the ability to do an analog load share line between the DGC HDs. So you can actually have kind of a redundant system built in. So in case the Ethernet lines get cut or the analog lines get cut, basically the load sharing will continue. We also have a third backup. We have the ability to program what's called droop. So in this industry, what's considered to be droop is basically as the percentage of load goes up on the gens, both the voltage and the frequency will actually droop down. So you'll start somewhere higher than, let's say 60 hertz for the US, 50 hertz for others. And you'll start at like 62 hertz and end up drooping down to 58 hertz by the time you get to 100% load. Same thing with KVAR. Our BestCom software tool, extremely flexible and configurable, as I stated a couple times. It's just a screenshot. And the upper left-hand side is what we call our metering section. Lower left-hand side is our configuration screens. What's nice with BestComs Plus software is all of the Basler software and tools work with all of the Basler equipment. So towards the middle of the screen, the dark black is a DEX voltage regulator, HD, DDC up on the upper right-hand side, and then other voltage regulators and excitation systems on the bottom. There is 6 levels of security that can be put into the BestCom software. So you are designing a system and you want to be able to have limited access for, let's say, an operator so that he can't go in and adjust settings. You can set that operator setting level 3, And then within the BestCom software, you can tell him what he is able to touch and adjust. He can view everything, but he won't be able to change any settings. So good level of security, especially with 6 different levels. We have several modes that we can use. So once you connect a PC and the BestComs Plus software to a DGC-2020HD, you can use it for programming the HD, but you can also go live. So what's nice is that you're trying to troubleshoot or commission. I expanded the upper left-hand side here, but you can see that in live mode, there is a bunch of different screens that will actually come up, and they're configurable. So you can look at circuit breakers, you can look at temperatures, pressures, basically everything that the DGC is actually monitoring or controlling. You can bring in live mode and multiple screens up here at the same time to be able to monitor what's going on. We also have a metering screen. So what's helpful here is, possibly during commissioning or testing, you can actually set the DGC and the BestCom software to record what is happening. And then you can export that out, and you can use that to go to an Excel spreadsheet or something and be able to view exactly what's happening over a period of time. Configuration exporting. So as I said, the BestCom software tool, you can work offline. You can build your configuration file and basically then download it into the DGC. What's nice is if you're coming up to a unit that you've not programmed, you can actually connect, and as long as you have access, you can download that program from the DGC, so you can actually utilize it for another application or utilize it for going back to the office or truck and changing settings, and then go back and download it and program to the DGC. Reporting and logging. So our event logging, we have 128 event types. There are 30 records per event. It is first in, first out. There's a maximum of 3,840 records that we can store. You can sort the record by a type, time, or engine hours. There's also a sequence of events, monitors internal and external status every 5 milliseconds. There are 400 monitor data set points, status points, configurable events. So you can actually configure this sequence of events to start recording when a certain event happens. So like if you happen to hit over voltage, you could set it so that it records after it hits the over voltage, and there's 2,048 events that are stored first in, first out as well again. Some of the adjustments for the governor. So if it's an external analog style governor, we can control it with voltage to plus or minus 10 volts, current of 4 to 20 milliamps, or pulse width modulation. If it's an ECU, then basically there's a drop down within the governor settings where you can select the governor and the ECU that you have. And again, just like the AVRs and stuff, that there's multiple drop downs that we already have pre-configured. AVR output is similar. So if it's an external analog bias to the voltage regulator, we have the same plus or minus 10 volts DC, 4 to 20 milliamps, or we can communicate over the CAN bus. This is a snapshot of one of the analysis that we can do in real-time monitor, watching the trending of what's happening. Here we have the system generator kilowatts and load bus voltage, and those are all selectable. Generator management. So as I had mentioned earlier, this is where you come in and basically tell the unit what type of system it is in and what type of breakers and generators it's controlling. As you can kind of see, I've got a couple of things highlighted here. So like if it's an island or if it's in mains parallel. Network configuration. So this is how the DDCs will talk to themselves in multiple gen application and setting up network configurations. Some more on the logic. There are 32 what we call levels. There's many gates that it can travel through before reaching an element. So basically you can have 32 and or nor timers, functions, blocks, but then after 32 it needs to hit a gate. What's nice is once you hit that gate, you can actually use that gate to go back into further logic. So there's multiple layers of logic that you can put in. 1,024 gates that are available, 32 timers, and we can do it both on a rising or falling edge triggered, 16 logic counters, 32 programmable elements with math functions. There's and, or, exclusive nor, and other gates. And you can say is 2 to 32 inputs per gate. We also have the ability to do a set and reset from a priority latch function block. So you can have a logic set up so that something occurs and you trigger a latch and it does an output, and then you can have a reset from a different function like clear alarm or etc. Toggle functions, both rising and falling edge triggers, and then what's really important, I think, and I don't have a really good shot of that on this one, the logic comment blocks. It's really nice, and it's very similar to like anybody's programmed PLCs where you can actually put comments over top of each run. That is also available in the Logic software tool, and it makes it extremely helpful if somebody goes out and has to troubleshoot it and he wasn't the one that wrote the logic. We have a full library of protections and options. This is an example at the bottom right-hand side of just a simple logic that's written on page 1. There's multiple pages. You can actually take and from one page to another page and jump. So even though to try and keep things cleaner, you don't want to put too much stuff on one logic page, you can then basically link it to a different logic page so you can see more of the logic instead of having to scroll up and scroll down a lot. Inputs and outputs, pretty self-explanatory, but basically you have an input in the middle that drives an output, and you can drive that output to a physical output, virtual output. We have both physical inputs, we have virtual switch inputs, which can be configured, which is nice. If for some reason you want to be able to do something during commissioning or testing or even troubleshooting through the BestCom software, once connected and in live mode, in that metering screen, you can open up a virtual input and be able to trigger an output just through the software tool. Further stuff on inputs, we've got alarms, pre-alarms, and all the different selections that you could ever think of. You can even see some here. We've got DEF, which is diesel exhaust fluid stuff, so that's getting read over the CAN bus. So depending on how the DGC-HD is set up, what it's set up to communicate with and monitor, these options show up to be able to use those in the logic. Outputs are the same, so we've got physical outputs, and then as you can see on the screen, we've got remote outputs, so that's the contact expansion module, so you can not only drive the outputs on the hardware itself on the DGC, but you can drive any of the accessory modules that are connected as well through the logic. Some of what we call components, so these are what we talked about, the ands and the ors, etc. Elements are elements, so we call them elements because Basler's kind of focused a lot in the protection relay world, and that's typically what the relay world uses, same with ANSI. So all of the elements are under the ANSI names, so like under voltage, over voltage, etc. There are also configurable elements, and then there's also elements that are functional things, so like closing the generator circuit breaker. You go into this logic and you're able to have whatever the input is, be able to close the generator circuit breaker. Same thing with the utility circuit breaker and many other functions. Pretty easy to navigate. It's drag and drop. So as you come into this middle screen, you basically pull the drop down, select what you want, leave your left finger on or leave the mouse click, whether you're left-handed or right-handed, and just drag it over into this area that I've got highlighted in blue. And then it's fairly easy is once you've got the logic and how you want the different functions or elements, basically you just click on the beginning state, drag it to the middle state, you drag it to the third state, and then third state you drag to your output. Again, this is just a small example of what I would call complex logic. We've got a lot of complex logic that gets much, much bigger than this, but you can see there's multiple things that are going to multiple different function blocks or gates, and then driving an output. Again, we've got alarms and pre-alarms that can be utilized in our logic. We also have an offline simulator, so once you build the logic, you can do an offline simulation and see how things are actually acting. And then last slide I've got is just to remind everybody that we've got 24-hour, 7 days a week, 365 days a year for technical support. Basler is one company. What's awesome is you have direct access to the technical experts and quick response times. So first question was about generator sequencing versus network configuration. The DGCs on their own communications network between them will be assigned an IP that you assign. It can also be the same IP that's on a building management network as well. Logic comments are stored in the configuration file or on the programming PC. Good question, didn't cover that. So in the BestCom software, as you're building it on your offline system, you can download both the configuration file or the logic file separately, or there is also a tab to download both of them. So all of the logic and all the configuration are stored on the DGCs. It's just making sure that you load them to that DGC either simultaneously or in two different steps. What is the distance limit for monitoring, or does the control panel connect to the internet? Can be monitored from anywhere? So I think the simplest answer there is standard Ethernet communications is about 300 meters. I have done ones that are longer than that. And basically, as long as you put an unmanaged Ethernet switch every 300 meters, it will continue. So it's no different than in a building. A lot of times there's an Ethernet that's run thousands of feet, but they just have to drop thousands of meters, sorry. They just have to drop a switch in between there to keep the boost up. And that's partly why we also have offered the fiber optic option, because fiber optic, you can go miles. Are all the wiring diagrams available somewhere? Yeah. So all of our, there's several Basler manuals, but the configuration manual is one that I was taking some snippets out today. It's pretty large. It also covers not only the wiring and the applications, but it also covers best comms and best logic as well. So it's all pretty much wrapped into one manual. Is it possible to include differential protection 87G in the DGC? Yes, sir, it is. Again, back to the style numbers. So if you look in the manual, there's an option for an enhanced, it's called, and it includes the 87G and 87N. Is the controller can handle main tie main applications? Yes. So we call it segmented bus, but a lot of other people in the industry call it a double-ended H. So you can have two utilities, right? You can have a bus tie breaker, and you can have two groups of generators. You can also, be able to do main tie main. As long as the main breakers are capable of being electrically operated, DGC-2020HD can do that as well. Is the software used for setup on the 2020 units open sourced? So no, the software is basically proprietary to Basler. So it's free, it's downloadable on our website. So it's all proprietary type of stuff, as well as the communications between the DGCs are all proprietary. I've been in this industry long enough that the question comes up all the time, and pretty much everybody is still using proprietary. There are a few competitors, I'll call them, that are starting to use CodeSys, but not a lot. So unfortunately, yes, today everything is through BestComs and is proprietary, as well as the communications back and forth to the DGCs. When to use load shedding? So load shedding is popular, especially in applications where you have multiple generators and multiple either transfer switches or circuit breaker pairs. I've seen a lot of this in hospitals, life safety, even data centers, where let's say you have 6 generators and 6 transfer switches, and you need at the minimum 5 generators to run all 6 transfer switches. And if for some reason you have to take one of those 5 that are offline, then basically it would transfer the, people will call it the lowest priority load. So it could typically be like something that's not of life critical situation. So it could be something that's backed up by the UPS already, or it could be outlets that don't need to be life safety, etc. So hopefully that answers your question. But what's nice is when you do load shedding, you can have 32 generators and you can have 32 load sheds. So if there's really a capability of disconnecting that load from the gen bus, it's fully capable of doing that. Thank you, everybody. Have a great day and be safe.